Alright guys, here we are with the second part of this video for section 1.6. We're looking at standardized test example number 3. So we're looking at the largest area. Yolanda has 26 centimeters of cording to frame a photograph in her scrapbook. Which of these shapes would use most or all of the cording and enclose the largest area? So we're talking about two things here. One thing we're talking about is using most of the cording would be the perimeter, and the enclosed area, we're talking about area. So we need to consider the perimeter and area for each of these shapes. So here in part A, we're dealing with a right triangle with each leg that's about 7 centimeters long. So whenever you have a situation that you're not given a picture in geometry, you want to draw the picture as best you can. So here's our right triangle. Each leg, we remember legs are the two sides that join together to form the 90-degree angle. Each leg is 7. Now, if the legs of our triangle is 7, we need to figure out what the hypotenuse is in order to find the first thing we need to do, which is the perimeter. So to find this hypotenuse, we remember that a squared plus b squared equals c squared when we're dealing with a right triangle. So that means 7 squared plus 7 squared is equal to c squared. C being the length of the hypotenuse. If we just take our time, we can figure out that 49 plus 49 is going to be c squared, which is 98 is equal to c squared. C is therefore approximately 9.9, and we use these kind of wavy equal signs to say it's approximation. I'm approximating that value. All right, so now that we know that C is that value, we're going to figure out the perimeter, which basically means to add up all of the sides. And we get 23.9 centimeters, which is using up a significant amount of the trim that we had. Now we've got to check for the area. If we remember, area of a triangle is equal to 1/2 base times height. The base here we could refer to as this leg 7, and the height is going to be 7 as well. So our area for this triangle will be 1/2 7 times 7. 7 times 7 being 49. If I take half of that, I end up with 24.5, and since we're dealing with area, we call it centimeters squared. So we're going to test this out for each of the next shapes. Let's check out the circle, and remember we're looking for the one that uses most of the cording and has the largest area when we're done. So if we look at part B is dealing with the circle, and we remember that to find the circumference of a circle, which is basically the perimeter, we have to do 2 times pi times r. So in this case, we'll get that the circumference of this particular circle is going to be 2 times pi times 4, which is 8 pi. And if we use 3.14 as our value for pi, we could approximate the circumference to be about 25.1 centimeters. And so now we see that we have a greater usage of that 26 centimeter of the 26 centimeter cording. Let's go ahead and find the area. Area of a circle is equal to pi r squared, and so we are going to take pi, we're going to multiply it by r squared, which is 4 squared, so we end up with 16 pi, which we can approximate its value as 50.24 or 50.2 centimeters squared. So clearly we've more than doubled this area. Let's see what happens when we look at different shapes, rectangle and a square. So we have this particular rectangle. We're going to look for the perimeter, which is the first thing we should do. The perimeter is going to be 2 times the length plus 2 times the width according to our formula, which makes sense, right? And then so 2 times the 8 plus 2 times the 4.5 is going to give me 16 plus 9. And so this perimeter has a value of 25. So we're using a good amount of the 26, not as much as the circle, but we're using a good amount of the 26 centimeters of cording. And let's check out the area. Area of a rectangle is going to be length times width, and so we'll be multiplying 8 times 4.5. And when we multiply 8 times 4.5, we get 36 centimeters squared, because we're dealing with centimeters, in each of these situations. And so you can see that C does not top out in terms of using the most chording and getting the largest area. So far we're looking at B. Let's try D. So here we've drawn a square where these hatch marks means that all the sides are equal and the length of one side is 6 centimeters. And so what we'll do is we'll find the perimeter. To find the perimeter of a square, it's always 4 times S, the length of the side. So 4 times 6 centimeters is going to leave me with 24 centimeters. Clearly this is not using as much of the chording as some of the other shapes. And then we'll do the area. The area of a square is equal to the side squared, or in this case 6 squared, which gives me 36 centimeters squared. And so the case has been made and we've tried every one, and we know that the correct answer would be the circle over here in part B. And we recall that in part B we got that the circumference, which is the same as the perimeter, used 25, let me try to write that a little bit better, 25.1 centimeters of chording, and the area of that circle gave us 50.2 centimeters squared space. All right, let's take a look at this next example. Here in example 4, we're looking to find the perimeter and area on the coordinate plane. So we remember from the last section that we were using the distance formula to find information about the distance or the length of a segment located on the coordinate plane. We're going to apply that right now. So we're looking for the perimeter of this particular shape. So we need to find the lengths of PQ, that's this segment here, and we're going to add the length of PR, sorry about that, and then we'll add also to that the length QR. Now hopefully you can see QR is pretty easy to get. We can literally just count right on the coordinate plane to get the distance, or we could simply realize that -3 and 4 is really representing the displacement, since everything is at -1 in terms of the x value, in terms of the y value. So we would find the difference between these two. 4 minus a -3 is a 7, and so the distance between Q and R is 7. And now we've got to use a little bit more skill to find these guys, but we can do it. So we'd have to use the distance formula. If you remember, the distance formula is equal to the square root of the difference between the x terms squared plus the difference between the y terms squared. And then we take the square root of it. So that's the distance, and so we can just apply that. Let's do that now. So let's first look at the distance between PQ. We've got to find the difference between the x terms. So the x terms are -3 and a -1. So we're doing -3 minus a -1 quantity squared plus difference between the y terms, -1 minus 3 quantity squared. And we can do the same thing for PR. We'll do the difference in the x terms, which is -1 minus 4 quantity squared. And over here we're going to add to that the difference between the y terms, 3 minus a -1 quantity squared. I know that's not clear. Let me try to write that again. Okay, so hopefully this is a little bit clearer. What we had written up here is a little bit clearly written here, and I've tried to color code it a bit. So with that in mind, let's go ahead and calculate the values. So we get -2 squared plus -4 squared square root plus -5 squared plus 4 squared square root plus 7. And if we continue on just a little bit more, we end up with 4 plus 16, which is the square root of 20 here, plus over here we get 25 plus 16, which is going to be the square root of 41, the square root of 41, and then we're going to add 7. So honestly, we could mathematically stop here and leave this somewhat unattractively, but we're going to probably join some like terms together. So I would put, if I wanted to leave it in exact form, I would do 7 plus, the square root of 20 can be broken down to 20, which is going to be 4 times 5, like that. So then I can take the square root of 4 and I get 2, so that can be written as 2 root 5, and then the square root of 41 is rather prime, so I'm going to have to leave it there. There's no way to simplify that. And so if I wanted to give an approximate answer, and let me use my wavy lines to approximate, the approximate value of this, I'd use a calculator and get about 17.9. All right, I do hope that that made sense. I know this one was a bit involved, but I hope most of these problems were kind of a little bit review. If not, that's okay. We can chit chat about it at a later time. I look forward to talking to you guys soon. Let me know if there's anything I can do to help, and I'll see you on Friday. Take care.